Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore a bold new idea that could change how we see the universe itself. What if gravity isn't just a force, but part of a much bigger system that processes information? Scientists are now asking whether this strange link could hint that reality works more like a simulation than we ever imagined. New research published by British theoretical physicist from the University of Portsmouth, Melvin Vopson, reveals a new role for gravity. His highly speculative and controversial idea is that gravity reduces information entropy, meaning that it helps in information processing, i.e., organizing, which is characteristic of a computational system. The paper has been peer-reviewed and published by the American Institute of Physics in mid-2025. Vopson's hypothesis draws upon the concept of entropic gravity, an idea first explored in 2011 by Dutch theoretical physicist Erik Verlinde. In Newtonian classical physics, mass attracts mass. Gravity is a force. In Einstein's general relativity, gravity is a space-time curvature caused by mass and energy. The concept is that gravity isn't a fundamental force, but an emergent phenomenon, something that appears from the collective behavior of smaller components. Just as temperature, which emerges from the motion of molecules, similarly, gravity might emerge from the way information is organized in the universe. Melvin Vopson further built on the previous ideas of Claude Shannon and Rolf Landauer's, which suggest that information is not abstract. There is a relation between information and thermodynamics. That information has a physical cost, such as energy, heat, and entropy, from which he induces that information must then obey laws like matter and energy. In classical physics, the second law of thermodynamics posits that the total entropy of an isolated system always increases. He proposes a new idea, which he calls the second law of infodynamics, which is contrary to traditional thermodynamics, suggesting that information entropy decreases over time. The second law of information dynamics requires information entropy to decrease. It requires less computational power and less data storage, said Vopson. I was a bit too brave. I postulated with a collaborator of mine that this is a universal law, but I only gave 2 examples. Since then, all my efforts were geared toward finding other systems where this is valid, Vopson said ambitiously. As he was trying to find evidence for his presumptuously declared law of the universe, he took COVID-19 as a specimen. After analyzing the readily available data related to the mutations of the SARS-CoV-2, the microscopic menace behind the pandemic, Vopson determined that when the virus mutated, information entropy decreased. According to Vopson, if the universe were a super-sophisticated simulation, it would require built-in optimization and compression to reduce complexity. So perhaps these genetic mutations are evidence of that optimization at work, since mutations appeared to decrease information entropy. He admits that the idea is speculative and in the realm of hypothesis. Despite 6 years of these kinds of rapid-fire bold claims, they are very far from certain. But he also acknowledges that he faced very little pushback from the scientific community. We have a public duty to publish results, publish ideas, bring them into the public domain so we can debate them, so we can disprove them, said Melvin Vopson. Thanks for tuning in to this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.